G'day guys and girls. What we've done up until now is we've used Psychopy, PyAudio, PySound to create, and Python, to create and play a whole range of visual stimuli and sound stimuli, and we've learned how we could change the parameters and do blocking and non-blocking ways of presenting stimuli. What we're going to do now is figure out a way of saving the data that our subject, bot, critter, mouse, human, whatever, what their response is, and saving that to a file which we can then look at later to analyze or import using Python or MATLAB or whatever you want to do. The file format that we're going to learn how to save here is called a CSV file format. If you're not familiar with the CSV file format, it's very common and it's pretty much used a lot when you want to create like a spreadsheet type of file. I know I'm simplifying it a lot for those people who do know what CSV files are, but it's a way that basically you can treat it and import it into Microsoft Excel if that's what you're comfortable with, and it will basically convert it into a spreadsheet with columns and rows. So we're going to use a couple of libraries here in our Python. The first one is called Pandas. And if we go to the documentation for Pandas, we go to pandas.pydata.org. It's a huge and really helpful and easy to use data analysis library. And what it does very powerfully is it gives us a quick and easy way of creating complex data structures, because it will do a lot of the hard work behind the scenes in getting the data into an appropriate structure and then allowing us to access the individual data points if we wanted to do that later. So there's two things that Pandas essentially makes. The first one is called a data series. So this is just the documentation. I encourage you to read the documentation. It is super helpful. So if you've got one-dimensional data series, so just a row of values in an array, or you've got a row of names, it doesn't have to be floats or integers. It could be integers, names, strings, characters, doubles, whatever. Okay. Pandas calls it a data series. So here you go here. That's a typical way of creating a data series. They call it spd.series data, okay? And it can become a dictionary or an ND array. Okay, so we're getting off track a little bit. So that's a one-dimensional array of data. What we're going to do is we're going to create a data frame, which is a two-dimensional data structure. And you can see, you can think of it like a spreadsheet or an SQL table. Oh, that's really good, because that's what we want to essentially create. More specifically, what's the sort of thing that we want to create here? Well, here is just a fake piece of data, or a fake experimental file that I've created. In my mind, I want to create the following data file. I want to have a column which has the subject's initials. I then want to have the time and the date when I did that particular experiment. I want to have the trial number, so we're going to do many hundreds of trials. Let's say this is a psychophysics experiment, so we need to do several hundred trials to get an accurate reading. And then we've got the stimulus parameters. So this could be a drifting grating or a static grating or something like that. And then this is the new thing. This is what the person responded. Was it correct or was it incorrect? Okay, so this is the sort of file that I want to save. We can see it's probably not going to be a Pandas data series, because we don't just have a single row here, but rather we've got a two-dimensional data structure, rows and columns. Okay, so what do we need to get started? We need the following libraries. We need Pandas, and we also need another library called pickle. Now we're going to use pickle as our backup. This is our just in case. So just in case our CSV file didn't save correctly, okay, and it's not a completely fatal error, we're going to create what's called a pickle file, which is a binary dump of exactly the same data as what we're going to send to our Pandas file. Okay, we're also going to need date, time, because remember we wanted to record the date and the time of when the experiment was conducted. We're also going to bring in Numpy, because Numpy can help us if we need to create just some temporary data to populate into our file, just to see if it's working. And the other thing that we're going to import is OS. So how do you make sure to see if you've got Pandas and pickle? Go to your command prompt, go to your Python, Again, remember, I'm using a 3.6.5. It's a little bit old now, but it should still work fine. And we're going to import Pandas, all lowercase, as PD. So this is a fairly standard way of getting Pandas in using that PD name. So we've got Pandas here. If you come up with an import error, module not found or something like that, what you can do is you can use your pip command prompt pip install Pandas or pip3 if you've got multiple versions. You've got Python 2 and Python 3 on your computer. Right, let's see if we've got import pickle, P-I-C-K-L-E, got that as well. Import OS, that's standard. And from datetime, import date time. So we've got all those. So if you get any errors out of importing any of those things, go to Google, get them in there, or sorry, go to your command prompt, use your pip installer, and then check to see if you've got them in there. We'll stop this video here. In the next video, we're going to learn how to create our data frame. Okay. In the meantime, if you want to take a break, go and have a read of that documentation from Pandas. Okay. I won't have the time here to go through exactly all the specific parts, but the information there is super helpful. And also, there's also cheat sheets. You can get cheat sheets out as well. Okay. Which basically go through quite simply the sorts of general commands and ways of interacting with the data. Okay, so I'll put that there. I'll stop this video here. I'll see you in the next video.